All right, so homework 12 is the beginning of chapter 2. I think I can write with that. It is going to take you back on this first question into that dark green section that was actually the arithmetic review, but you know, they move stuff around and whatever. So this is now in chapter 2, but it's still in the first slice of your pie chart. It says, on a survey, 6 students reported how many minutes it takes them to travel to school. Here are their responses. 7, 12, 4, 16, 4, and 6. We want to find the mean travel time for these students. Mean is your fancy math word for finding the average of something. When you find the average, you add your numbers together, find that answer, and then divide by how many numbers are on your list. So in this case, we're going to start by doing 7 plus 13 plus 4 plus 16 plus 4 plus 6. If you want to use your calculator, you can use your calculator, but this list happens to be easy enough to add. 7 plus 13 is 20. 4 plus 16 is also 20, and 4 plus 6 is 10. So 20 plus 20 plus 10 is 50. You do want to make sure you get that sum before you try to divide, because if you punch in your list and just do divided by 6, it's going to follow the order of operations and only do 6 divided by 6. So we need the 50 first, then we're going to divide that by 6. That you probably want to do on your calculator, because most of the time it's not going to come out to a nice whole number. I can tell that because it tells me I have to round my answer. So on your calculator, if you do 50 divided by 6, you come up with 8.33333 and so forth. We want to round to the nearest tenth. The tenth spot is how many places after the decimal? Just one. So I look here, I look at the number behind it, it's less than 5, so I just drop those off. So 8.3 is the average time. So when you find the mean, when you get your answer, you want to kind of look, is 8.3 somewhere in the middle of that list? Yeah, it's somewhere in the middle of that list. If I would have got 80, I would know I did something wrong, because 80 is way bigger than all the rest of my numbers, right? And the average should be somewhere in the middle of your list. I'm going to move that up for number 2 here. So, a pet store has 8 cats. Here are their weights in pounds. Go ahead and start adding. 11 plus 8 plus 13 plus 10 plus 12 plus 13 plus 11 plus 12. I'm not going to add it. I'm going to let you guys add it. 90. Everybody getting 90? You were the only one who did it. So I'm going to take 90 and I'm going to divide that by 8, because we had 8 numbers on our list. And we take 90 divided by 8, it comes up with 11.25. If I round that to the nearest tenth, then I'm going to round it off to 11.3, because there's a 2 in the 10th spot, but there's a 5 behind it, so I've got to round it up. So 11.3. So again, and I look and say, oh yeah, 11.3 somewhere in the middle of the list of numbers. Looks like it should be the right answer. So go ahead, do number 3 there. I'm going to take a bite of my hot pocket, because when it cools off it gets kind of crunchy. So when you added all 7 of those numbers together, you came up with
72.
72?
73.
73. 73. You divided it by
7
students, and 73 divided by 7 gave you
10.4285714.
And if I round that to the nearest tenth, then I'd give my answer as 10.4. which again is somewhere in the middle of my list, between the highest and lowest numbers anyway. And so it looks like a good answer. Now the next one you actually already did in the review. You had 4 topics that were in the third slice of your pie that you did in chapter review in chapter 1, but I just wanted to review it with you before we went on to all the rest of the stuff. So this one's probably not going to show up on your pie chart because you probably already did it. We said that when we were solving for a variable that had adding and subtracting next to it, we moved that number over to the other side of my equation by doing the opposite. If I have v minus 6 equals 7, I would want to move my 6 over here to the other side. Since it's a minus 6, we're going to add the 6 to move it over. 7 plus 6 gives me 13 for my value for v. If I was going to check that, 13 minus 6, sure enough, is equal to 7. Yes, that makes sense. So on number 5, if I want to solve that for x, what should I do?
Move the 2.
Move the 2, so I'm going to subtract the 2, right? Since it's a plus 2, I'm going to minus the 2. X then equals 5. 5 plus 2 is 7. Number 6, if I want to solve that for y, I'm going to move the 5 by subtracting it, right? Subtract the 5 and y equals 3. 5 plus 3 is 8. So those ones we should have done when we worked on the review section. And now the new ones now just are the same thing you're doing, just making them a little more complicated. Like we might have fractions and decimals and those kind of things. But the rule is still the same. If I want to solve this for y, I need to move this to the other side. So I'm going to add my 3/4. Since I'm adding with mixed numbers, I'm going to put it underneath because I know I have to add my fractions first and find my common denominator. My common denominator on this one is going to be 20. So making my equivalent fractions. 5 goes into 20 4 times. 4 times 3 gives me 12. So I have 12 20ths. 4 goes into 20 5 times. 5 times 3 is 15. And then I added those. 12 plus 15 is 27 20ths. We said then we were going to change that into a mixed number since we can't reduce it down because we're working with mixed numbers. So 27 20ths would be what? 1 and 7 20ths. Then we have to add that 8 that's up there. And so 8 plus 1 and 7 20ths gives you 9 and 7 20ths, right? So we get some practice working with our fractions and using our rule for solving equations.
That's what y equals.
That's what y is equal to, yes.
Okay.
So number 8, if I want to solve that for v, what should I do to solve that for v? Move the 2/3 by subtracting. I'm going to subtract my 2/3. Again, I'm subtracting, so I'm going to find my common denominator, which is 6. 1/2 is equal to how many 6? 3. 2/3 is equal to how many 6? 4. I can't take 4 away from 3, so I end up having to borrow. I borrow 1 from the 3 and make it a 2, and what do I add to my 3 6? 6 6, right? Remember when I borrowed 1? I had to do it in terms of my denominator, so 1 is 6 6. So 3 6 plus 6 6 is now 9 6. Then now I can take 9 6 minus 4 6, then I get 5 6. Can't simplify that, but I still have this 2 up here. So 2 and 5 6 is what v is going to be equal to. See, we can't forget our first chapter we did. It keeps coming back. So number 9, I want to solve that for x. I am going to do what?
5/1.
I'm going going to subtract my 1/2. I could make this 5 over 1 and just make a big improper fraction, in which case my common denominator is 2. This is still going to be minus 1/2, and this would be how many halves? 10. Right? 5 over 1 is equal to 10 over 2. 10 minus 1 is 9 halves, which as a mixed number would be 4 1/2. Not probably the way the Alex program would have done that subtraction, but it works. Here's what they would have done. If they would have done 5 minus 1/2, they would have said, I can't take a half away from nothing, so they would have borrowed 1 and made this 4, and 1 would have been 2 halves. 2 halves minus 1/2 is 1/2, and look it, I got the same answer both ways. Both of them are mathematically correct, so whichever way you're more comfortable doing it works. And I didn't even need my calculator. So now they throw in the decimals. I'm still doing that same property I had before. I want to get the y by itself, so what am I going to do? Minus the 2.28, right? 5.79 minus 2.28 gives me 3.51. So number 11, if I want to solve that for x, I would. So subtract my 1.81, right? Since it's a plus, I'm going to make it a minus when I move it over. If I subtract there, 5.35 is what x is going to be equal to. Number 12, if I want to solve that one for x, what should I do? Add the 3.85, exactly. Add the 3.85. These guys must have already did them. They're adding way faster than you can do it in your head. No. 6.41. Now it says I'm doing the additive property of equations with integers. What were integers again?
Whole numbers.
Whole numbers that are positive, negative, or 0. So now we got the rules for integers with our adding and subtracting. If I want to solve this for v, I'm going to minus the 3, right? Subtract the 3. So a negative 4 minus a 3 gives me negative 7, because I have to add and keep my signs since they're both negative, right? So number 14, if I want to solve that for y, I'm going to add the 6. So y is going to equal negative 8 plus 6 would be negative 2, exactly. And number 15, if I want to solve that for u, I'm going to add the 2. Negative 7 plus 2 is negative 5. Gosh, you guys are good. You just whipped right through those ones. The next property there that we're going to have is the multiplication property of equality. If I want to get rid of multiplying, I divide. If I want to get rid of dividing, I multiply. The sign is not going to change because we're not doing the opposite of adding and subtracting. We're doing the opposite of multiplying or dividing. So in this case, this says 52 equals 2w, which means 2 times w. To get rid of the 2, which is called your coefficient, I'm going to divide both sides by 2 technically. Gets rid of the 2. 52 divided by 2 is 26 for my answer for w. We know that if we took 2 times 26, we get 52. They might also have it this way. This expression means u divided by 4 because fractions are division. What number divided by 4 is 92? In order to get the u by itself, you do the opposite of dividing, so you end up multiplying both sides by 4. The 4's then cancel out, and u equals 92 times 4. Figure those girls already had it done. 368. 368 divided by 4 is 92. So number 18, if we have 3x equals 84 and I want to solve that for x, I'm going to divide by that 3. This is showing multiplying. I do the opposite, which is dividing. So 84 divided by 3 was what? 28. If I took 3 times 28, I should get 84. Now they're going to do them with integers, so I have to remember my rules for my signed numbers. When I multiply and divide, if my signs are the same, my answer is positive, and if my signs are opposite, my answer is negative. So she's already trying to figure out the answer, but she better do a right sign on here. If I'm going to solve this for y, I'm going to divide by that negative 2. The sign isn't going to change when I do dividing. Now I'm going to find the sign of my answer. Positive 24 divided by negative 2 gives me negative 12. So you get really used to on those adding and subtracting ones. Oh, I got to change my sign. And then you get to the multiplying and dividing, you think, do I have to change my sign? No, I don't. Now, this is a tricky one. This is negative w divided by 8 equals negative 41. This negative can either be put with the w or with the negative 8, not with both, because then I'd have a negative over a negative. Since I want to get the w by itself, I'm going to put the negative with that number. W over negative 8 equals negative 41. It's one of the very few times I actually put the negative on the bottom of my fraction. Otherwise, it makes my problem longer. So if I want to solve this for w, I'm going to end up doing what? Multiplying by that negative 8. That cancels out the 8 and the negative sign all at once so that I can get my w by itself. On the other side, negative 41 times a negative 8 gives me a... what was my sign in that? What was the sign on your answer? Positive 328. Because I have a negative times a negative, so I end up with a positive number. So, one of the few times when you have a fraction, you actually want to put the negative with the bottom number because you want to solve it for the w, and you don't want the negative with the w. So number 21, we want to solve that for y, and so we're going to divide by my negative 8, and so y is going to equal 2. Negative 8 times 2 gives me negative 16. So, on your little pie chart, you should have in the third slice, I can't remember exactly what color it was, 4 things already done that were in the chapter 1 and in the review. So, the next 6 things, because one of them was a review thing, should follow along there in that next slice there. Unless you already did them. Some of you already have them done.